So guys, in the previous classes, we have started with the concept of transaction management, right? Meaning that if something is going to be happen on the database, how this database is handling those transactions. That is what we are trying to study, right? So if a particular transaction is executing, there is no problem for us. I mean, if there is only one transaction called S1, if itself is going to be executed on the database, there is no problem. But if multiple transactions are there, like S1 is one kind of a set of transactions, it contains transaction T1 and transaction T2, transaction T3 and so on, Tn transactions are there, then there might be a problem. What might be the problem? If these transactions are going to be executed in a concurrent fashion, definitely there is going to be a certain kind of problem. That problem might lead your database into an inconsistent state, meaning that if you take your database data at any point of time, they are going to be different, inconsistent, right? So for example, if you take the variable a, or if you take the data item a, if somebody is trying to add 100 rupees to this data item and somebody is trying to subtract 100 rupees from this data item a, then if the initial value of this a is 500, at any point of time, what about the value of this a? 500 only, right? This is what called as consistent state, right? So you have to think about this consistency of the database when concurrent executions are going to be happening. But there are another kind of transactions are there, they are going to be called as serial execution. When serial execution, there is no problem. But if it comes of the concurrent execution, definitely there might be a problems which might lead to inconsistency. For that, we have to think about various kind of cases. So that's the reason, to overcome the drawback of inconsistency, we are moving for various kind of scheduling, right? But here also in scheduling concept, whatever things that we are trying to discuss, we are always going to concentrate on various kind of non-serial schedules, which maybe behave as serializability or not. Why we are thinking about, why we are more curious about serializability? Because if I am able to find out any kind of non-serial schedule, so that which may have high server utilization, am I right? If I say that any kind of non-serial schedule, right? The advantage of non-serial schedule is high server utilization. The advantage of serial schedule is correct data. But if you take the non-serial schedule, it is going to have incorrect data. We are searching for a kind of non-serial schedule which will produce correct data, so that which may have high server utilization. That kind of thing we are going to call it as serializable, right? So at what time we are trying to check? At the end of the code, means up to now whatever things that we have seen, we are trying to write one non-serial schedule S dash and another serial schedule S. We are trying to check whether these two are serializability or not, in terms of result serializability, view serializability or conflict serializability. Then I can say that a particular non-serial schedule S dash is the effective one compared to serial schedule also, because it may have high server utilization. Okay. So if you are able to observe clearly, the problem with this particular scenario is, after completion of the entire program, we are trying to define the solution for it, right? But there is no advantage of this one. See, for example, if I say I am going to write a program, the program name is something like insertion short. If I am saying that insertion short, where I have written the set of lines of code, after that I am trying to write its time complexity, which is of big O of n square, right? At what time I have done? I have done the time complexity of this insertion short after writing the entire code. But is it the correct one? Or if I am able to analyze in some manner, so that I can able to expect the written code time complexity is big O of n square. Which is the best one? Second one is the best one. Why? Means we are going to reduce the time write the entire this code. Before this itself, we are going to identify the big O of n square. Array, why can't we go for this insertion short? Can we go for any kind of time complex which is going to take less than big O of n square or not? The same thing here is going to here also, right? So after writing the entire non-serial schedule and checking with respect to serial schedule, and based on the result, we are saying that yes, this is the best one. This is the best one, right? Instead of this one, before writing the code itself, can we able to find certain kind of non-serial schedule which may lead to finding the non-serial schedule or not? That's the reason we are moving for various kind of protocols. We can basically call it as concurrent control protocols. Concurrent control protocols, right? So these concurrent protocols basically defines, which is simply a process of managing concurrent execution of transactions. Concurrent execution of transactions, which we call it as concurrent control protocols, right? So the same meaning which we are going to get in the schedule also, right? Which is meant for the purpose of managing the concurrent executions of various kind of transactions only, right? So the same meaning here itself, but the thing is here what we are going to do before going to write the code itself, we can able to define it. Those protocols we can call it as concurrent control protocols, and we can able to observe various kind of concurrent protocols are there. Among those, one is log based protocol. Again, log based protocol is classified as simple locking or binary lock. Two-phase locking, again it is classified. Timestamp based protocols, multiple granted protocol, multi-version protocols. Okay, these are the various kind of concurrency protocols are there. In our syllabus, we are going to have only these two. So we'll try to discuss all these things in these particular classes. Okay, fine. So now let us see the first one, log based protocols. Right? So guys, here just think about my example what I am trying to give. If I am going to have any kind of thing like transaction T1 and transaction T2, right? I am trying to perform some kind of write operation on A, and then I am trying to perform some write operation on A, and then I am trying to perform some kind of read operation on A. Right? What I am trying to do here, I have a single data item A, The same data item is going to be executed by T1 and T2 concurrently. What might be the problems are you going to face here? One is cascading rollback, which you can directly understood. The reason is, if something is going to be happen at this point of time, if rollback is going to happen, that is going to be affected all the remaining transactions also. We can simply call it as cascading rollback. Okay, fine. So this is what actually a scheduling is going to happen. To overcome this drawback, we are going to use some kind of commit operation. We can able to get all the problems. Or else, instead of this, can we go for some kind of locking mechanism? The problem with the earlier one is, as this data item is going to be accessed by multiple transactions, there is a problem. What is that? We are facing the rollback also. Right? Instead of it, can we make some kind of lock on this particular variable A? What is the meaning of a lock? Simply making a lock it and should not used by any other one. Right? So if I am going to have a house, if I am going to make some kind of lock, nobody cannot able to access it. Right? When I am going to release it, if somebody wants to access it, I can able to release it. Right? So basically, this lock is a kind of a variable which we can use it for in two ways. One is a kind of shared lock. Another one is exclusive lock. Shared lock means the name itself is clearly providing. Shared means which is sharing among all the people. When we can able to share a data item to all the people, if all people are trying to access read operation R1, R2 and so on, Rn, all the transactions are trying to perform read operation over the data item A, can we allow them? Yes or no? It's a kind of basic common sense. We can able to allow them to read. But if I am able to, if somebody like asking for something like Tn plus 1 transaction, is asking for to perform write operation on this transaction, can we able to allow them? No, because it's going to get a conflict, right? So means write read, read write, write write. These should not be allowed concurrently. This should not be allowed concurrently. Right? So here shared lock is defining that if somebody is trying to ask for shared lock, that basically defined technically as lock underscore s of a. What is the meaning of this one? I have applied shared lock on variable a, or I have requested shared lock for a, right? So now is a is now accessible by any kind of a lock? No, as of now it is no. So now I have asked for shared lock of a, right? Now if somebody is asking for again some transaction T2 lock of s on a, can I allow? Try to observe. This is asked by T1. This is asked by T2. Can I allow? Yes or no? As they are shared lock means they are asking for read lock. I can able to definitely allow. There is no problem. But if somebody is asking for some other kind of a lock, which we can call it as exclusive lock. Exclusive, right? Exclusive lock means which is specifically meant for the process of write operation, right? Now if I am asking for exclusive lock of a by T3, can I allow T3 transaction? No, because if I allow, T1 is performing read operation on a, T2 allows in performing read operation on a, and T3 is performing write operation. At that time definitely there is going to be a conflict between multiple operations. That's the reason if one person is trying to perform read operation, I should not allow any other kind of operations that can be in terms of write operation. Or if somebody is trying to perform write operation, I should not allow any kind of read operation, right? So means if somebody is trying to access a particular data item A that can have a maximum capacity of n persons can able to read, but if one person allowed to perform exclusive lock, you cannot able to allow any other person even read operation also. Means on a particular data item of exclusive lock of A, only one person is going to be allowed. That is the meaning of exclusive lock. Okay, means if I say in terms of some diagram format, if I am going to have shared lock and exclusive lock, shared lock, exclusive lock. If somebody is trying to perform shared lock on a particular variable data item A, can I allow it for another shared lock? Yes. Shared lock and exclusive lock? No. Exclusive lock and shared lock? No. Exclusive lock and exclusive lock? No. This is a general kind of thing what we discussed. I have drawn in form of some kind of representation. Right? This kind of mechanism we'll call it as simple locking. So whatever things that we discussed so far will be called it as simple locking or binary lock. Means if somebody wants to perform read operation, I have to take compulsory shared lock. If somebody wants to perform write operation, I have to compulsory take the exclusive lock. This procedure, if it is going to be followed by any transaction, I can call that transaction will becomes under concurrency control protocol transaction, right? For example, if I say transaction T1 and transaction T2, T1 transaction T2, I am trying to perform lock underscore S of A, read of A, write of A, lock underscore X of A, write of A. I am trying to perform unlock of A, and here I am trying to perform unlock of B. For example, this might be a B. This might be a B, right? Now, if you are able to observe, is it will be comes under a kind of simple locking? No. The reason is when you are trying to access any kind of data item, that must should have to be comes under either shared lock or exclusive lock. If you are able to take here B, have we defined any kind of operation for this? No. So this particular schedule itself is not going to become under simple locking, basic thing, right? So to make it into a kind of any kind of a locking mechanism, first you have to apply some kind of locking. It can be any kind of write operation, it can be any kind of read operation. But as I'm trying to perform write operation, what kind of lock you have to take? Exclusive lock, right? Lock underscore x of good. If I'm going to take lock underscore exclusive of b, definitely it's going to be considered now simple locking. Now, is there any problem are you going to face? Yes, there might be various kind of problems you are going to face. Why? So one kind of problem is you are going to face inconsistency. I mean, even if you are going to apply some kind of simple locking mechanism, definitely is going to produce inconsistency. In what sense it is going to produce inconsistency? See, for example, if I say transaction T1 and transaction T2, I am trying to perform shared lock on A, and I am trying to perform read operation on A, and then I am trying to perform unlock of A. Again, I am trying to perform exclusive lock of A equal to A minus 50. This example earlier I have taken. For that I have added locking mechanism. A equal to A minus 50, and then I am trying to perform write of A, unlock of exclusive of A. See guys, here sometimes we may write unlock of A or unlock of exclusive of A, whatever it may be, right? So basically, why this kind of scenario is correct? Once we applied some lock, I cannot able to grant another lock. That's the reason. Even if I am not going to mention X also, by default it is going to consider exclusive lock only, because if it is allowed, it can be unlocked. Right? So that's the reason I have written. Now, if you are able to observe, if something is going to be happen at this point of time, meaning that now I am trying to perform something like read operation of A. I have applied shared lock on A, some read operation on A I have done. If something is going to be happen, some failure might be done. If failure might be done, definitely your database is going to be in an inconsistent state. Right? The reason is, even you are trying to perform some kind of locking mechanism, your database may produce in the inconsistency. So simple locking mechanism drawback is inconsistency. So this is one kind of problem what we are facing. If you take one more example, if I try to write T1, T2, I have applied some kind of exclusive lock on A, and this particular transaction applying some kind of locking mechanism on B. Is there any problem up to now? There is no problem. If you are assuming that there are two data items A and B, and both transactions are trying to use both data items. Now, so far, T1 is asking for A data item. Yes, it has using, because nobody is using, allocated. Now, T2 is asking for B data item. Yes, it is allocated because nobody is using. Now, if it wants to complete this transaction, it requires one more kind of data item B. Right? I mean, if you are able to observe somewhere, A equal to A minus 50, B equal to B plus 10. If you are able to observe, right? As I am trying to perform write operation, so compulsory I need to acquire some kind of exclusive lock. At the same time, for T2 also somewhere, it is asking for some kind of write operation. So, on the data item A, then what they have to take? Exclusive on A. Now, what might be the situation happening here? Is it going to be executed from this point of time? What I am saying here, see, observe. If I am going to have transaction T1 and transaction T2, right? At the first step, T1 have got the variable A because nobody using, and T2 got the variable B because nobody using so far, right? But what about the next step? We are asking for exclusive lock of B, right? When I am asking the exclusive lock of B, can I able to grant it? No, because which is used by already someone. If it is shared lock and I am asking for shared lock, it will be accepted. But as I am asking for exclusive lock, which is already given to some person to the exclusive lock. So what might be happen? This is simply requesting for B. Requesting for B. What about the other situation? If you take the next one, exclusive lock of A, T2 is now waiting for whom? A. Waiting for A, right? Now if you are able to observe, simply A is using by T1 and which is waiting for B. Which is waiting for B. B is using by T2 which is waiting for A. Right? Is it a kind of some kind of locking mechanism? We can simply technically call it as deadlock. Right? So means from the block line onwards, from this line onwards, is it going to be executed? No, because they are completely when the next step is going to be executed, once the current step is executed, then only we will move for the next step. Right? As the current steps are not executing because of these things, we cannot able to move further. So the entire schedule is going to be stopped. It's going to be stopped, right? So this the problem what we are going to face in the simple locking mechanism. Right? This is also one kind of problem. And there is one more kind of problem is there. The problem is if you are going to take the transaction T1 and T2, I am trying to apply lock of exclusive lock of an A and I am trying to perform some kind of let it be any kind of write operation and I am trying to perform here exclusive lock of A. Before this I have done exclusive lock of unlock. So when I am going to perform exclusive unlock, is there any problem for you? So far there is no problem because it is executing perfectly. Now I am trying to perform write off A. If I am trying to perform write off A, what might be the problem you are going to face? Think about it. So if you are going to say write off A, here you are going to get certain kind of problem. So I am expecting the answer from you. That's why I am waiting. What might be the problem? Is it going to be a kind of correct transaction or is it going to be a kind of incorrect transaction? According to the earlier discussions, this is what kind of conflict? Right conflict, right? When right conflict is going to be happen, suppose at this point of time, if something is going to be happen, failure. What might be happening? Rollback, right? Rollbacking of one transaction is going to roll back of all the remaining transactions, right? Meaning that even the simple locking mechanism cannot able to avoid the rollbacking mechanism. In addition words, if I say in another manner, it is not going to get the concept of serializability. So the reason is if I say transaction T1, transaction T2, what might be the conflict happening here? T1 followed by T2, right? For example, if I say here there is one more kind of problem. Again there is a kind of write here. Now again T2 for T2 and T1 again there is a conflict. If there is a conflict, I have to draw the line. Right? So this is what a conflict serializability or non-conflict serializability. So when there is a loop, it is going to be a non-conflict serializability. But what we are expecting? Serializable schedules we are expecting, right? But even you are using here a correct way of locking and unlocking, you are going to get always non-serializable schedules. That's the reason I can say that this is also a problem what we are going to face in the simple locking, right? So to overcome these drawbacks, we are moving for further a kind of locking mechanism. We can call it as two-phase locking mechanism. Two-phase locking mechanism. In two-phase locking, earlier we made a locking on randomly. If I would like to use, I am going to apply some lock and I will use, right, based on the read or based on the write. But here what they are trying to say now, to overcome all the drawbacks what we are facing here, they are saying that we need to have two kind of phases. One is, we can technically call it as growing phase. Another one we call it as shrinking phase. Shrinking phase. I mean, if I more deep into this particular definition, growing phase means always whatever the order you are trying to execute, first you need to acquire all the locks. Acquire all the locks, then you go for releasing the locks. Release the locks, right? So what is the reason why we got here non-serializability, not conflict serializability రావడానికి కారణం ఏంటి? Because if I are able to observe, at the middle I have unlocked it. At the middle I have unlocked it, and after some time again I am trying to use it, right? If I say that if I'm not going to unlock this one, what might be happen? Is there any chance given to this T2 transaction? No, only T1 will execute completely. So then there is a problem of avoiding it, right? So that's the reason they are moving for this concept. First, you need to go for complete acquire the locks wherever you are trying to use. Then once you start releasing the locks, try to release all the locks depending upon the situation. This is what you can call as two-phase locking mechanism, right? So basically this kind of mechanism we can call it as basic 2PL mechanism. In basic 2PL mechanism, we are going to have all the lock acquired first. Later part we are going to release the locks. This particular point we call it as lock point. So lock point technically means the point where you are going to release starts its locks. We're going to release starts its locks. We can call it as a lock point, right? Basically the main advantage of two-phase locking is it is going to get the concept of serializability. Serializability, right? So mainly it is going to get the overcome the drawback of this earlier problem of simple locking mechanism. So that's the reason we are moving for two-phase locking. Okay, now fine. So if you want some example, if I say something like transaction T1, transaction T2 and transaction T3 are the three transactions. So if I say something like lock of A, I have applied exclusive lock of A. Very good. Share lock on A, I have applied share lock on A for the T3, and I have applied exclusive lock of B. Exclusive lock of B, unlock of A, lock of exclusive lock of something like C, unlock of B, unlock of A, unlock of C. Unlock of C. For example, if we eliminate the T1 transaction, now is it becomes under two-phase locking? Is it becomes under two-phase locking? Yes. The reason is once a transaction is started, if you are able to observe, wherever it is going, always it is going to acquire the locks. Always going to, once it start unlocking, this point I can call it as lock point. See, I am trying to say with respect to T2. Once it starts unlocking, it's all completely unlocking. Okay now. Similarly, if I are able to observe the transaction T3, once it starts its locking mechanism, that can be a scheduled lock, that can be exclusive lock, okay. But once it starts its releasing of unlocking operation, it is going to perform unlocking. So this will becomes under two-phase locking mechanism. We can call it as basic 2PL, right? Simply, if you are going to have acquiring the locks, you have to be always in acquiring lock mechanism. Once you start the releasing of locks, you have to be always in the releasing locks. So this particular procedure definitely going to avoid the problem of serializability. Okay, fine. But this particular procedure having a problem. What might be the problem? Again, what might be the earlier problems? Is those earlier problems are going to be overcome? Is the deadlock is going to be overcome? No, right? If simply if I say exclusive lock of A, exclusive lock of B, exclusive lock of A, exclusive lock of B, or if I write in some other order, exclusive lock of B, exclusive lock of B, exclusive lock of A, and I am trying to start unlocking of all the remaining things after some lines of code. Now this particular thing is a kind of a basic 2PL. Is it a basic 2PL or not? Yes. What is the meaning of basic 2PL? First it has to acquire all the locks. Yes, done independently. Then it is going to release the locks. Yes, done. But is it going to be the work on the drawback of deadlock? No. So the problem here is one of the drawback of basic 2PL is definitely deadlock. Definitely deadlock. And if you are able to clearly observe, okay, fine, as per the execution point, it is working fine if you are able to observe. But if somewhere, for example, exclusive lock of B, it is done. Here I have performed some kind of exclusive lock of B. Exclusive lock of B. Is it going to be allowed? It is going to be simple locking only. I mean, it is going to be basic 2PL only. Why it is basic 2PL? Because locking, and followed by unlocking. Basic 2PL. But what about the execution? Which one is going to be completed first? T2 is going to be executed complete first because at this point of time it is waiting for release of lock of B. But when it is going to be release the lock of B? At the end of the T2 only, right? So at the end of the T2, once it's done, then it starts executing again, right? Yes. But here if you observe one thing, so for example, if I unlocked the B at this point itself, then this is going to be executed. Okay, now fine. So now it will become under basic 2PL. Basic 2PL only, because up to here it is locking and it is unlocking. There is no problem. But if you are able to clearly observe, if at this point of time, if after executing the lock exclusive of B, at this point of time, if it again got a chance to execute something in T2, and that might be fail. That might be fail. Right? If it is going to be fail, what will happen? Rollbacking of this transaction is going to roll back off all the remaining transactions what so far used, right? Until commit has done, right? So that's the reason. This is what we can call it as cascade rollback. So in basic 2PL, we are going to face these two problems. One is deadlock mechanism, another one is cascade rollback. So to overcome these two drawbacks, we are moving for further. That is conservative 2PL. Conservative 2PL, right? So this conservative 2PL advantage is it will definitely eliminate the problem of deadlock, but not the remaining maybe. It will compulsorily eliminate the problem of deadlock, but may not be the remaining problems. So why it is going to compulsorily eliminate the deadlock means, conservative 2PL means if I say transaction T1 and transaction T2 are the two transactions, if they are trying to execute it, if they want to complete its execution, whatever the data items that they require, they has to compulsory acquire at the starting of the transaction only. At the starting of transaction only. Then definitely is going to eliminate the problem of deadlock. Why? Earlier, if I say exclusive of A, exclusive of B, exclusive of B, exclusive of A, right? So here, what do you think that this one? Assume that this is a kind of a read of A, something like read of B. Assume, right? Now, if I are able to clearly observe, what does the meaning of conservative 2PL? If I say the transaction T1, if it is performing exclusive lock of A, done. Okay. In future, what might be the data items it is going to use? B also it is going to be used, right? At the initial of the transaction itself, all those should be acquired before going to execute all the remaining code. But what is happening here? In middle, we got a kind of read operation. Read operation, right? Parallelly, this is going to be executed by some other thing, right? So this is where we got the deadlock. So to overcome this drawback, what we are going for? We are going to go for conservative 2PL. In conservative 2PL, what we are trying to say, whatever the transaction that we required, those transaction lock should be acquired at the earlier itself. See, if it got the chance, yes, it will be executed. If it is not getting the chance, after some time at least it is going to be executed. At least the worst case. But if you take the earlier one, even after many hours of time also, they are not going to be released by one among each other, right? But if you take this particular situation, definitely they are going to be acquired. If you say lock of A, lock of B, right? So this is what you can call as conservative 2PL. Right? So here, if I say something like this, D and C and D, then it is going to be definitely conservative 2PL. If I take here, you may get question, sir, if I take here A, B, is it a deadlock? No, it is not going to be deadlock. Why it is not going to be deadlock? Because initially it got the chance to execute it as T1 is acquired by A and B, and T2 is trying to forcefully get the A and B locks. But as it got handover to transaction T1, T2 cannot move further its execution. Meanwhile, all the remaining operations of the T1 is going to be executed. Once it executes, at any cost, at the worst time also, it is going to unlock off those A and B. Then it starts its execution. So this is where your deadlock is going to be eliminated. So that is why we can call it as conservative. Conservative means what? It conserved a lot of time, right? But at the worst case, it is going to eliminate the deadlock concept. Deadlock concept, right? Yes, ma'am. What about like any kind of serializability or any kind of other problems? You have to think all those things. So if we say here the drawback, what about cascadeless or cascade rollback? Is there any point what we are discussing? Like for example, if I say here C and here D and D, and I am trying to execute all the remaining things, trying to roll back of this particular transaction, is it going to be rollback of all our remaining transactions or not? Definitely, because we haven't used anywhere commit operation, definitely is going to be rollback operation. That's the problem. So to overcome this drawback, again we are moving for more stricter versions. We call it as strict 2PL. In strict 2PL, what they are trying to say, if I am going to have transaction T1 and transaction T2, if you are going to get exclusive locks and you are going to get shared locks, whatever it may be, all locks are acquired, and once you start unlocking, there is no problem. It is working fine. When there might be the problem means, if I say here, there is a write operation of A. Exclusive lock we got, and we are trying to perform unlock of A, and we are trying to perform some kind of write operation. Now, at this point of time, if there is any rollback, what will happen? Rollback of this transaction will lead to rollback of all other remaining transactions. Rollback of all other remaining transactions. Why? Because we haven't used any kind of commit operation. So to overcome the drawback, what they are trying to say na, when you are trying to perform any kind of unlock operation, we are trying to perform any like of unlock operation, before that unlock you have to make sure that commit operation you have to do, right? So if you are able to observe, simply write off a, so some blah blah operation is going to be done, some commit unlock of a, then here I am trying to perform some exclusive lock and write operation, right? If you haven't used here commit command, what might be the problem? Definitely it is going to have rollback problem. But if some rollback is going to be happen, where it is going to be rollback only the where uncommitted transactions are going to roll back, but it is not going to be effect for all the remaining things, right? And there is no problem of inconsistency because it has read the committed data. This is where strict to PL is saying, right? The meaning is transaction TI should not release any exclusive lock until commit or abort, right? If it is going to release the exclusive lock, what might be happening? Rollbacking may be happening. That is the advantage of strict to PL. If you take any kind of another kind of conflicts, what it might be, it's all about like write, right? But there are certain situations write read may be happening, right? Something like earlier discussions of strict schedule, right? So it's not only about write operations, you have to take care about all of its locks. It's not only about like read lock or write lock, you have to take care of all the locks. They must and should have to be commit before releasing them. Whether it may be shared lock, whether it may be exclusive lock, you have to take care of all those things. Okay. This is what the meaning of regress to PL. So the difference is here we are thinking about only exclusive lock release when the commit happened. Whereas coming to here, you have to release the lock once any kind of commit operation is done, right? So if you are able to observe the representation, which one is the best one? Rigorous, obviously, right? So regress to PL is superior than strict to PL, which is superior than conservative to PL, right? So I mean, if I draw conservative to PL, strict to PL and regress to PL, is it the correct one? Again the question, right? Every regress to PL may not be every strict to PL can be a regress to PL. No. See, if you draw this one first, we'll draw for these two. Is it correct? No. Regress to PL should be superior for now strict to PL. Not superior. In terms of rules, it is okay. But what about Venn diagram representation? If I say that it is a regress to PL, it is a strict to PL. But if I say that it is a strict to PL, but it may not be a regress to PL, right? So you have to make sure to modify this one. Now it should be conservative to PL. Conservative is going to be definitely outside, but it is going to overcome the problems of deadlocks, right? So you can just represent like this, or I will redraw this one once again. Regress to PL, every regress to PL is going to be a strict to PL. Okay. If you have any doubt regarding the conservative to PL, you can go for up to here. The relation between those things. Okay. Fine. Now tell me, which are the following is strict to PL? Clearly observe, What is the meaning of strict 2PL? You have to perform commit operation before performing any kind of unlock write operation. If there is any kind of exclusive lock, if I am trying to release it, before it has to be performed commit, right? First, let us take the first one. Is there any commit have you observed? No. So definitely it is going to be a not strict 2PL. What about the B? Is it a strict 2PL? See, observe. First, before going for strict 2PL, whether it is a 2PL or not. Yes, it is 2PL because first acquired all the locks. This is lock point. Again, I am unlocking all the things. Right? Now, lock shared of A, lock exclusive of B, unlock of A, unlock of B. Right? Here you got the commit. You got the commit. Is there any problem? Is it can I call it as strict 2PL? It is following the principle what we discussed, so it will come under strict 2PL. Can I call it as rigorous 2PL? No. Rigorous 2PL means you have to make sure always use the commit irrespective of any kind of lock, irrespective of any kind of release of the lock. Okay. So it is strict 2PL. What about the C option? Is it a strict 2PL? Yes, of course. It is a strict 2PL. Right? So option D anyway eliminated. So option B and C are the correct answers. This is one of the gate question actually. Right? At the time they have given both options are correct. Take out this one. Tell me which of the following are basic 2PL, conservative 2PL, strict 2PL and rigorous 2PL. So let us try to solve from the first one onwards. Is it a basic 2PL? Is it a basic 2PL? No, definitely no, right? As it is not basic 2PL, all the remaining things are not going to be considered, right? Why it is not basic 2PL? First it has started the locking and then it has done unlock. Once it starts unlocking, you have to have always only unlocking. But here if you are able to observe locking mechanism, so it will becomes under not basic 2PL. Okay, what about the option B? Is it a basic 2PL? Yes. So they performed locking. Once it starts unlocking, they are trying to perform unlock operation. So it is basic 2PL definitely. What about conservative 2PL? What is the definition of conservative 2PL? Huh? You have to get all the transactions data item should be at the initial itself, right? If you take here, what kind of transactions this particular transaction is using? A comma B, right? What is the definition of conservative 2PL? Whatever the item that I am trying to use in future, in order to avoid deadlock, I have to get all those acquiring of those items should be at the initial stage itself. But if you are able to observe, I have acquired the serial lock of A and immediately I started the next level, right? But I missed the acquiring of exclusive of B, right? So is it a kind of conservative 2PL? No, very good. What about strict 2PL? Strict 2PL? Strict 2PL is not possible because there is no commit before unlocking of B and A, because both are write operations. So it is not strict 2PL. As it is not strict 2PL, it is not going to be a rigorous 2PL. What about this C1? Is it a basic 2PL? Yes. Once it starts unlocking, yes, unlocking. Done, basic 2PL. What about conservative 2PL? It is again not the conservative 2PL because acquiring of all locks is not done at the initial stage itself. What about strict 2PL? I think it is yes. What about rigorous 2PL? No. Unlock of B done with commit. What about unlock of A? No commit. That's the reason it is not rigorous 2PL. Is it okay everyone? Yes. Yes. So this is what all about various kind of two-phase locking and simple locking mechanisms. Okay. So in the next